Hello, good afternoon, folks. This is Amir McKean coming to you again from AICpublications.com, here with another tutorial in our 10-minute engineering program that we're putting together. And we are creating these videos primarily so that we can increase the representation of African Americans in the science, technology, engineering, and mathematical fields. Many African Americans are widely underrepresented. So, myself being an electrical engineer with many years of experience, I decided to put together some of these tutorials that you can find at AICpublications.com with other books and things that we're writing so that we can demystify the math and simplify the science so that many of your children, maybe some of you, won't be so intimidated and refrain from using that brilliant, creative, inventive, and innovative mind that you have from learning how to master technology. A lot of times, when technology spreads, when it grows, when it moves into another direction and it becomes highly profitable, African Americans get locked out. And there are several reasons behind that. But this particular 10-minute engineering program that we've created is to address the idea of representation and the way that information is actually presented. So today, what I wanted to go back with you on is the subject of turning an NPN and a PNP transistor on and off. And that's the lesson of today's uh, aspect. Basically, these two devices, both transistors, are a fundamental aspect to everything that you see in technology today. And I'm going to just give you a very basic demonstration of it. All right. As with anything, as I myself, as an electrical engineer, I always start with a block diagram because we use the math to understand how to control, how to manipulate, how to manage, how to massage what is happening in each of these blocks. And it's the math that allows us to go into the block and change the functionality, change the behavior of each block. The reason why we do a block diagram is so that we can actually take our ideas out of our brain and put them onto paper so that we can actually formulate everything that we want to do so that when it goes to being produced on a mass scale, or we want to have a patent for it for whatever reason, people will be able to follow our thought processes. All right. And be able to do it and be able to troubleshoot it later because we're going to forget certain things. So we start off with what we want to do. What we want to do is have light indicators in this so that we can actually see when the transistors are turning on, when they're turning off, and then be able to understand what's making them turn on and off. We're going to have a speed rate changer that allows the lights to be able to change state. So there's going to have to be some kind of mechanism that we put into this circuit that's going to give us this functionality. Then we're going to have a normally off switch, which is the PNP transistor that we're demonstrating the functionality of. Then we'll have a normally on switch, which is the NPN transistor. All of that would be meaningless without a power source. And in this application, we're actually going to have two power sources. And I'll explain that right now. Let's go over the circuit that we've created and designed. Okay. The first block that we just talked about is the power source. And this is going to actually be the positive rail power source. Now, the way that electric current flows, it flows from positive charge all the way to the negative charge or the ground. That is the way that conventional, normal, positively charged current flows. And with a NPN transistor, that is the normal way of flowing. However, with a PNP type transistor, not pointing in is an NPN, and pointing in with the arrow is a PNP. With a PNP transistor, the current flow is the exact opposite. So we need two power supplies, one that's a positive power supply, which we have here with a positive 9 volts, and one down here, which is a negative power supply, which is a negative 9 volts. And if you can see, we have the short lead, which is the negative lead of the battery, connected, pulling these processes down. And we up here, we have the long lead of the battery, of the 9-volt battery, connected, pulling the positive current and supplying that positive current. Here we have a variable resistor, which is a potentiometer, which allows us to change the resistance. When in R1, we have a variable resistor, which allows us to change the resistance from 0 all the way up to 100,000. In R2, we have a 5600 ohm resistor. In R3, we have a 1200 ohm resistor. And this purpose of R3 is just to generate a current so that we can flow the current down to these transistors. The output, which is what we care about, is going to be in between both the NPN transistor, which is normally on, or excuse me, the PNP, which is, or excuse me, the NPN, which is normally on, and the PNP transistor, which is normally off. All right. So what is happening here is these two transistors are controlled by the voltage that's at the gate. So long story short, for the normally on transistor, whenever there is a voltage that's positive greater than 0.7 volts, this transistor here, the NPN, will conduct current from the base, which is coming from VB, all the way down to where you see the arrow flowing out, and the green LED should turn on. Whenever there is a negative current, negative 0.7 or less than that, then the PNP transistor, which is normally off, will conduct. In other words, you'll get current flowing from the into the base negatively. So when that negative current comes, the green LED is going to go off and the red LED will turn on. Current will flow from the red LED into Q1 through the collector, which is the arrow, and into the base and down into that more negative 9-volt source. So what we're going to do right now is we're going to go to the circuit itself and we're going to take a look at how it functions. So right now you are looking at PNP resistor, which is right here, which is Q1, and you're looking at the NPN transistor, which is U1. Here is your 1200 ohm resistor. Here is the variable potentiometer resistor, and coming right next to that is the 5600 ohm resistor. The bottom of the 56 ohm resistor, which you cannot see, let's see if I can move that right there without you losing sight of the light, is connected to minus 9 volts. Minus 9 volts is just a 9 volt connected backwards. That's all. Just like the regular plus 9 volts is a 9 volt connected in correct form, forward form, we'll say. So we're going to turn on the plus 9 volt and we're going to turn on the minus 9 volt. And what I'm going to do in order for you to see it clearer, let's see if I can get rid of the, there we go. Now, if you can look here, you will see that the green LED is lit. All right. So what I'm going to do now, I'm going to adjust the voltage. I'm going to adjust the resistor. which right now is at 0 ohms. So because it's at 0 ohms, we're going to get this voltage right here. And then I'm going to take this up and turn this up. So when we increase the resistance, we actually bias the junction, the base voltage, with a negative voltage. Now, how can we prove this? Let's turn on our meter, and we're going to look here. I'm going to readjust this light again. And as we can see here, it is listed right now at a -1 volt. And as soon as we go positive at that gate voltage, we begin to see the positive flow of the green diode, of the green LED. And you can see this transition period right here happens right around the base of the voltage turning negative. So again, we turn it positive, a greater than 700 millivolts or 0.7. The green LED comes on. We go negative. The red LED comes on. Thus, the transistor function is exactly the way that it should be. So I'm going to change the layout again for a moment. And we will, let me get out of there. And we're going to come back here. Let me add our layout back to the screen. We're going to add our schematic back to the screen so that you can understand how we did this again and can relate to it. So again, you see when the voltage goes negative, we're getting the green, or when it goes positive, the green LED is on. And when it goes, when the base voltage goes negative, we get the red LED to come on. So what we're seeing here, give me a moment, I'm going to change this camera and we'll get another angle. And we'll come back from the circuit there. And what we're doing here is explaining to you how this works. Now, this is the fundamental building block of this. So what we've learned, as we've already stated, is that the NPN positive base voltage turns on in forward bias mode, or when a positive current is supplied by a positive voltage. The PNP transistor turns on when a negative current is supplied by a negative voltage. Base voltage of both transistors is controlled by the variable resistor or the potentiometer that we had. And what does the math say? As we always say at AICpublications.com, can we listen to the math? Can we talk with the math? The math here basically says that 0.7 volts and negative 0.7 volts literally is the sweet spot for both NPN and PNP transistors. And we just proved that with our circuit. Now, this application is a fundamental way for you to understand how PNP transistors work, how NPN transistors work, and understanding the applications of this. These type of configurations are actually used in power supplies for computers. Even though what I just showed you is a old circuit, this circuit still exists in technology today, and it will exist in future technology applications. It's the building blocks for logic integrated circuits. It's going to be used. It's already being used in AIs. It's already being used in cryptocurrency. It's being used in cybersecurity because it's one of the basic building blocks. So if you want a career in STEM, if you want to be an entrepreneur based in technology, you have to understand the building blocks of it. Listen, if you've enjoyed this, you can come to AICpublications.com, get yourself a free book. We're doing a book called The Basic 8, in which we take you through the 8 basic functions of building blocks of technology. Look forward to talking with you. Look forward to interacting with you. Leave some comments, ask a question, and let us know basically what you think. You can find us at AICpublications.com. Here, we want every member of our audience to attain the knowledge, innovate for success, command your future. Till next time, take care. Peace. Thanks.